Welcome back to another episode in my proof series where I focus on proving why certain things happen in mathematics. This episode will be why the derivative of inverse of cosec x or arccsc of x equals negative 1 over x square root x squared minus 1. Now these are the same thing, obviously. They're just written differently, with one with the power of negative 1 and this one with an arc at the front. Okay. Let's get right into it. So we begin with our function. That function will equal cosec to the power of negative 1 x. Now, if we had something like this, cosec fx equals x, and we wanted to find fx, we would put the inverse on the other side. That's when you're trying to find angles or trying to find the fx on its own, you would have to bring this over with an inverse, which is basically what this is. Now, all I'm doing here is just reversing that process. Okay? So I'm just getting rid of the inverse and putting it back on this side with the positive power. Okay? So, now that we've got that out of the way, we're going to derive each side. So, we'll start with the left side. Derivative of cosec of fx, we use the chain rule. Derive the outside first. We get negative cosec fx multiplied by cotangent fx multiplied by the derivative of the inside. If fx is the derivative, if fx is the function, derivative would be f dash of x. Now the right hand side, which is just x, so the derivative is 1. Now I'm going to rearrange this to get f dash of x on its own. So that will mean I'll have to divide both sides by cosec fx multiplied by cotangent fx. Okay? That's what we'll get. Now, I'm just gonna rewrite this with the negative out the front because I don't want anyone to get confused. Hopefully you're not already confused. Okay? So what I do is just bring the negative out the front, because the negative on the bottom or the top means the whole fractions are negative, so this is the same thing. Now we're going to focus on cosec fx and cotangent fx, just the bottom line. Okay. Now, if you've watched my video, I think I did it in my tangent, or no, my secant video, my sec to the power of negative 1x video. I basically square rooted the whole lot, the whole bottom, and it will look like this. Negative 1 square root cosec fx multiplied by cot fx. Now for this to be the same, if I'm going to square root it, I have to square both of these. Now why? Because the squared will cancel, the squared on both of these will cancel out the square root. So this still equals this, okay? By having a square root and both of them being squared, it's the same as writing this. I'm just writing it differently. So if you think about it in a way, I'm complicating it in order to simplify it. So what am I going to do now? Well, I'm going to split them up. Cosec squared fx multiplied by square root of cotangent squared fx. Now, my final goal is to try and find cosec fx so I can use x's instead of all this rubbish. So, if we look at this, we've got negative, we got a square root cosec squared fx. That is the same as having a cosec squared fx. just a normal cosec, sorry, my bad. The squared cancels out the square root, so it looks like that. Now that equals x. That means that I can replace this with x in the next line. I could have negative 1 over x instead of that. See? And what I'm going to try and do with this, when I multiply it onto whatever I further on with this, I'm going to try and find a way that I can get cosec out of cot. Now, there is an indices law that states that 1 plus cotangent squared fx equals cosec squared fx. You will see this law most likely with a theta, but I'm just replacing it with fx, because as long as you have in the variables in cot and cosec, as long as they're the same, it doesn't matter. So what I'm going to do is rearrange it so I have cot squared on its own, which means I'll have cot squared fx equals cosec squared fx minus 1, because all I did was just subtract 1. Bring the 1 over to the other side. Okay, so this is what we have. We have a cot squared fx, so we're going to replace it with the cosec squared fx minus 1. Still going to be a square root, we just replace the stuff on the inside. Cosec squared fx minus 1. Now, we established that cosec fx equals x. Therefore, cosec squared fx must equal x squared. Okay? Because if I had this and I was to square one side, I would have to square the other. Therefore, cosec squared fx would equal x squared. And then we get this. And that would be the derivative. Okay? So if I rewrite that on another page for you, we have our function, and that equals the inverse cosec of x, and the derivative will equal negative 1 over x multiplied by square root of x squared minus 1. Thanks for watching. I hope you learnt something, and have a good day.